While we have seen strings in just about every example of Python code that we've looked at so far, we really haven't taken much time to step back and think about what strings are and see what they're capable of. So we're going to do that now. A string is a sequence of characters. It can contain any kind of characters, alphabetical characters, numeric characters, spaces, punctuation, and even some special characters that we won't even necessarily see or that do different layout and spacing things. A string can be in Python in single quotes or in double quotes. This is a little different than many programming languages. In many programming languages, Java, for example, a string has to be inside of double quotes, and only a single character can be inside of single quotes. But in Python, that's not true. You can enclose a string in two double quotes, or you can enclose a string in two single quotes. The only rule really about that is that if you started with a double quote, you must end with a double quote, and likewise, if you started with a single quote, then you must end with a single quote. You also, it's worth noting, can make multi-line strings by doing 3 quotes at the start and 3 quotes at the end, and that will allow you to have multiple lines in your string where you just hit enter to make the next line. There are many different operations that can be done on strings. You'll find that one of the aspects of Python that comes up time and again is that there's a similar interface and set of operations between lots of different data types wherever it's possible to have a similar approach to how to do it. One example of this is that strings can be indexed just like lists can. So I could ask for the value at index 0, and that would give me a capital P in the course name that's shown here. I could ask for the value at index 1, and that would give me the lowercase r. What I've shown here is asking for the value at index 2, which would give me the lowercase o there. It's also worth noting that what I get as a result of doing that indexing, in this case, is actually itself a string. It's a string that is 1 character long. That is a little different from the list version of this, because in the case of a list, you don't get a list back from using a single valued index. So that's a little different here. What I get back will still be a string, just a string that's 1 character long here. And I could do this with any valid index up to the length of the string minus 1. Just like with lists, you can do it for any index up to the length of the list minus 1. You can also use those negative values to index from the right-hand side backwards, like we saw in lists. So another thing that we can do with strings, similar to lists, is slicing, getting a section of the middle, beginning, or end of a string, just like we did with lists. So here I've defined my pet name to be Jimmy the cat, and if I ask for my pet name 3:7 inside of square brackets, then just like we saw before for lists, the first element that's included would be the element at index 3. And the last element that would be included is at the index 6, because the 7 that's given here is excluded. So here I get my space t. So I get out a portion of the string. And again, the result of doing this is itself a string. So you might be able to imagine how you could use this kind of thing to get parts of your strings, for example, pairs of letters, or groups of 4 letters, or things like that. And here are the other examples of slicing again, where I can give a start index, but not an end index, which will go from my start index all the way to the end of the string. I can also not give a start index and only give an end index, which will go from index 0 to 1 before the end index that I've given. Another thing that's pretty parallel to how lists are done is that you can loop over strings. You can loop over each character in the string with a for loop. For example, here I've defined course name equals programming and problem solving, and then I'm looping over each character. I've called my loop variable C. Now again, I say character, but it will be a string that is 1 character long. So I loop over each character in course name, and I can print that character. That would print each character from this string on its own line. And you could imagine I could do things to those characters. I could shift them in the alphabet in some amount. I could make them uppercase or lowercase. Lots of different things that I could potentially do. Count how many times capital P repeats throughout those characters. Lots of options there. I also can loop using the index, similar to how I could have done for a list as well. I can ask the length of a string with the same exact function name as I use for the length of a list, len, and then parentheses, and then the name of the string variable. And so here I'm also printing out each character from the string course name, but what I also have available is the index that that character lives at. So this is the sort of thing where I could print out not just the character, but if I wanted to, I could also print what index it's at. I could keep track of all of the indices where capital P's appear, or different things like that. But this is a pretty straightforward example where all we're doing is printing out each character from the course name on its own line, and we're doing it only a little bit differently because we're looking it up by index here. We also can use the plus operator to combine or concatenate strings. Concatenate, as you may have seen for lists, is just another word for combining two groupings. While a string is a grouping of characters and a list is a grouping of elements, so I can use the plus operator to combine or concatenate different strings. So here I build the string programming and problem solving by using the plus operator between a few different strings that contain parts of programming and problem solving. And you could do this to combine all of the user input that has been given to you, or taking user input and embedding it in a sentence that you've already structured, or lots of different things like that. Strings also have many of their own functions or methods that you'll be able to call using the dot operator, like we've seen when we called things from libraries, or perhaps in a few other cases that we've looked at, where you have some variable name here, for instance, newtext, and we call a function related to newtext. And for instance, here we've got upper and lower, which will create for us new strings that are the uppercase version of newtext. So all characters that are alphabetical will be converted to their uppercase version if they're not already, or kept as their uppercase version if they already were uppercase. So the R's will stay uppercase, and the rest of it will get converted to uppercase in this first line. And in the second line, we'll get a new string again that is all of the characters converted to lowercase. So the R's will become lowercase, and every other alphabetical character will stay lowercase. So when we go to print, the original will still be the same, because in the case of strings, they are immutable or unchangeable, in other words. I cannot take this existing string here, new text, and change the first character to be B instead of W. I can create a new string that has a B as the first character and shares every other character in common, has a copy of every other character from new text. You can do that. And that's what these methods are doing here, is they're creating uppercase versions of new text or lowercase versions of new text, but not changing the original version that existed. So new text, when it prints with only the R's uppercased, and then upper text will print with all of the characters uppercased, and lower text will print with all of the characters lowercased. None of them will affect each other in that case, in that situation. It's also worth noting that every character in Python, and in most any programming language, is stored by associating it with a number. There are multiple different schemes that you'll run across for what defines these numbers, but most of them are built on the same initial small set, and then they may have larger and larger sets of characters that are available. So the original or the older one that you will often see is the ASCII encoding, ASCII, and it defines a relatively small set of characters in which, for instance, uppercase A is stored as the number 65, and uppercase B is stored as the number 66. You may start to logically already see what 67 might represent. And similarly, lowercase a is stored as the number 97, lowercase b as the number 98, and the digits and other types of non-alphabetical characters also get their own values. Another more complex character encoding that you will see is Unicode, and it has, as I say, many, many more characters available in it than the older ASCII encoding. But they mostly share this set of what letters and digits and some of the most common English punctuation maps to. This allows the computer to store all of these different data types in numeric ways, which of course then get converted to binary on hard drives or in memory. So we will look in some of our assignments at how these encodings work. You can create a character, or in other words, a single character string in Python by calling the chr function with a number like 97, and it will generate for you the character lowercase a. They really are the same thing in memory or on the hard drive. It's just how the programming language thinks of the type of data that you're dealing with. And likewise, you can turn a character into its ordinal value. That's what the ORD in this slide stands for, by calling the ORD function with that character. So if I call ORD on the number or the character that contains the number 5, or that represents the number 5, then I'll get out the number 53. These, by the way, are statements of truth. They are not valid Python. You could not say ord a equals 97. You could say ord a double equals 97, and it would always be true. One other thing to be aware of in terms of strings is the empty string. Much like with lists, we had the empty list that we could start from. We also, in strings, have an empty string. You can create a version of the empty string by putting two quotes, one after the other, with nothing in between. Quotes and a space is not an empty string. Quotes and anything in between them is not an empty string. It's worth noting, so that you're aware of it for later points when you might encounter it in theory classes or in later programming classes, that this is often symbolized as epsilon. And that can be written in English, the English word epsilon for the Greek letter, and therefore you can also represent it as the Greek letter epsilon. So empty strings are very, very often used to be the start value of an accumulator variable, where you're building up more and more into a string. So overall, strings are any sequence of characters. In Python, you can use double quotes or single quotes to enclose a string literal, a string that you have coded and defined its exact details. You also can build up strings using operators like the plus operator, and you can get new strings based on an existing one by using functions like the upper and lower function. And we'll see many more of these kinds of functions as we move on and deal more with string operations and string methods here soon.